ACPA LRFD bridge design under Section 12 allows for direct or indirect design of concrete pipe. Direct design is a very calculation-heavy method to determine the reinforcing and concrete requirements in concrete pipe. Indirect design allows you to determine the load-carrying capacity of a pipe by utilizing a simplified relationship between the installed condition and a test condition in the plant. While both methods have their uses, today's tutorial is going to discuss the use of fill height tables for indirect design. These tables have been produced by the American Concrete Pipe Association and they meet LRFD design requirements. To use these fill height tables, first you need to determine the soil type you will be using for your project. There are a variety of materials you can choose from, whether in situ soils or purchased materials that will be shipped to the job site. The soil that you select will affect your pipe design and installation requirements. On page 3 of the fill height table, you will find the Unified Soil Classification Table for standard installation soil designations under Table 2. This table will list soils in different categories based on the soil stiffness or strength that is inherent in each soil type. Table 1 lists the 4 standard installation types that are available for reinforced concrete pipe. Each standard installation has minimum compaction requirements for the various allowed soil types. This standard installation table lists installation types from a Type 1 to a Type 4. These installation types are based on how much the supporting soil structure contributes to the total structural strength of the installed pipe system. A Type 1 installation requires a Category 1 soil to be compacted to 95% proctor density up to the spring line in the haunch and outer bedding. Because you are using a soil with a higher stiffness based on the soil and the compaction of the soil, you will be building more of the structural support for your system in the soil itself and would therefore need a lower class of pipe. If you choose a Type 4 installation, you are taking very little structural support from the soils, so your pipe will need to be stronger, or a higher class of pipe, to support the load over top of it. This gives you, as the designer, options when doing an indirect design as to how much influence you want from the soil based on materials that are available on the job site and the amount of effort that will be required by the installer. Due to long-term soil settlement in embankment installations and soil friction forces present in a trench installation, concrete pipes installed in an embankment installation receive greater loads than a pipe in a trench installation with the same amount of cover. With this in mind, all of the fill height tables were developed based on embankment installations, which result in conservative designs when used for trench installations. To use the tables, you will need to determine what pipe size is required, how much cover you will have over your installed pipe. The installation method is already determined for you as the tables use a conservative embankment installation. Now you have enough information to go into the tables and select the installation type that suits your projects based on available soils and contractor installation requirements. Let's look at an example. Let's say you are designing a project with 36-inch reinforced concrete pipe. You will have 10 feet of cover over the pipe, and we will look at a Type 4 installation versus a Type 1 installation so you can see the difference. So if we look at a Type 4 bedding, which again we are taking more of our structural strength from the pipe versus the soils, keep in mind these tables are designed utilizing a soil weight of 120 PCF, ACPA HL 93 live load, and an embankment installation. Again, very conservative if your design is a trench installation. So we find our pipe on the table. In this case, we stated it was going to be a 36-inch pipe with 10 feet of cover. The color coding in the table tells us that this is a Class 4 pipe. And you see that based on this information, the pipe must carry 1,518 pounds per foot of ID per foot of length. If you reference ASTM C76, you will find that a Class 4 pipe must be manufactured to carry a minimum of 2,000 pounds per foot of ID per foot of length. Let's look at where this information comes from in ASTM C76. All reinforced concrete pipe is designed based on how much load it can carry. If we look at C76 Class 4, you will understand that this specification tells us, as manufacturers, how to build a reinforced concrete pipe to carry specific loads. In this instance, a Class 4 pipe has to be able to carry 2,000 pounds per foot of ID per foot of length before it gets a 0.01 crack. This specification tells us, the manufacturers, what the compressive strength of the concrete has to be and the steel placement in the pipe to meet this load requirement. This also carries a safety factor of 1.5. So let's take a look at a Type 1 bedding. Again, this table is based on the soils being 120 PCF, AASHTO HL93 live load, and embankment conditions. Since we are using a higher soil stiffness under a Type 1 bedding in the haunch and outer bedding of our design, we're producing more of the structure in the soils versus from the pipe. So we're looking at a 36-inch pipe with 10 feet of cover, and in this instance we are able to use a Class 1 pipe for our design. Remember, as the soil structure increases, using better soils and better compaction efforts, the lower the strength class of pipe that is required. Remember, these fill height tables are based on established test criteria and ASTM standards. We have them available for circular and elliptical pipe. Thank you for your time today. If you have any questions on how to use these fill height tables, please contact the Concrete Pipe Association of Michigan or any of the concrete pipe producers in the state.